Hi, this is Fazana and welcome to Fazmaths. In this video we'll look at some circle theorem questions and I'll show you how to approach these questions. As important as the circle theorems themselves, always remember to mark your radii. Yeah? Once you do, it'll be able to spot any isosceles triangles. Start making the diagram your own as soon as you see it and as you're reading the question. It's a sheer joy when you've arrived at the answers even before you get to them. Let's start. In the diagram below, points Q and S lie on a circle center O. The minute you see center, you're thinking either radius meets tangent or the diameter or angle at the center is twice the angle at the circumference. So all these things should be flying around in your head as long as you know the theorems well. So here we can tell radius meets tangent. So that's 90 degrees. Okay, and as soon as I've read that first sentence, I look at the diagram again and I mark my radii. The minute you mark your radii, you can see that's an isosceles triangle. So that's 80. So those two will be 180 minus the 80, which is 100, and then half them, and you'll get 50. Okay, so each one of these is 50. All right. If that's 90, then that is 40. So can you see I've hardly read the question and I've already started marking on the diagram. So I've made the diagram my own because that's where they set the questions from. So you've got to reclaim this diagram as your own. Okay. SR is a tangent to the circle. Yes, we got that. Oops, sorry. Angle QRS is 40 and angle SOQ is 80. Prove that triangle QSR is isosceles. Can you see we've already proved it? All right. So we've proved that that's isosceles. Okay, so let's go for it. So we say angle OSQ equals 50 degrees. I always put my explanations in brackets and it just makes it look so neat. So you go triangle OSQ isosceles, and it's isosceles because of two radii. Okay, and then we talk about that being a right angle triangle. So angle OSR equals 90 degrees. And why is it 90? Because radius meets tangent. Okay, and then the last one, we got that 50, we made that 90, so therefore angle QSR equals 40. 90 degrees minus the 50 degrees. Therefore triangle QSR isosceles. Okay, remember you have to give your explanations for each step of the way. All right, that was good, wasn't it? Okay, let's move on to the next question. Points P, Q, R, and S lie on a circle. Remember, if you ever get 4 points lying on a circle, just more often than not, it's going to be a cyclic quadrilateral. Do you remember I said in a cyclic quadrilateral, all 4 points touch the circumference of the circle? In this case it isn't, but just look out for it, okay? And PQ equals QR. So you know that's isosceles. So straight away I'm going 180 minus 116, which is 64. And then I divide it by 2, and I get 32. Yeah, so each one of these is 32. Okay, so angle QPR equals 32. Yeah, okay, and that is because triangle QPR is isosceles. Okay, so that's 32, and it says explain why angle QSR is 32. And the reason it's 32 is angles in the same segment are equal, yeah, or angles extended by the same arc. Yeah, so can you see that angle and that angle has been extended by the same arc? Yeah, so you say angle QSR equals 32, and then in brackets angles extended by same arc equal. Okay, yeah, all right, that was good, wasn't it? Okay, next. All right, this one's quite a popular question, and it's nice because there's actually an ability to self-check your answer so that at the end of the day you know you're absolutely right. Yeah, in the diagram, A, B, C, and D are points on the circumference of the circle. Okay, so we can see the cyclic quadrilateral. Yeah, okay, so the minute you see those 4 points there, okay, so if that's 70, you know opposite angles in a cyclic quadrilateral add up to 180. So immediately we know that's 110. Okay, yeah. And I've got the center again. So the center could be radius meets tangent. There's no tangent. So there's no tangent. So angle at the center is twice the angle at the circumference. So you can see that arrowhead. Yeah? So you can see that's 140. Okay? And always write it because it's so easy to half that rather than double it. Yeah? Okay, so that's 140. So when they say work out the value of x, we've got 140. Give a reason for your answer. So you say angle at center twice angle at circumference. Okay, work out the value of y, so that's 110, and the reason, opposite angles in cyclic quad. You can't do that, yeah, you've got to write the whole thing. Yeah, add up to 180. Okay, now there is a way to check this because you know angles around a whole point come to 360. So 360 minus the 140 is 220. And can you see here, you've got angle at the center, 220, is twice the angle at the circumference of 110. Yeah, so we've checked it and we're so good. All right, yeah, that's a good one, isn't it? Good. Okay, this one. If you've watched part 1 where I discussed the theorems, this one's a bit of a trick question because you can see the bow tie. Yeah, so you think, oh, it's angles extended by the same arc. Yeah, but it's actually not. Let's just read the question. The diagram shows a circle center O. So again, when I see the center, I'm always thinking about radius meets tangent. So that's 90 degrees. Yeah, okay. So that center just gives you 0.5 quite a few theorems to think about. So I've got that being 90. Those two have to be 90. So that will be 90 minus 36, which is 54. Okay, so again, can you see I haven't really read much, and I've already started marking on the diagram. A, B, and C are points on the circumference. DCO is a straight line. Okay, DA is a tangent, so we've got that bit. Angle ADO equals 36. Work out the size of angle AOD. Okay, so we've got AOD is 54. Yeah, and the reason being, and you have to talk about, sorry, no brackets there. So you got angle OAD equals 90 degrees, and in brackets radius meets tangent, and then angle AOD equals 54 because angles in a triangle equals 180. Okay, yeah. Sorry, seems to have cut off another question here. So part B was work out the size of angle ABC. Okay, so that one there. And here, as I said, it's not 54, so it's not angles in the same segment. It's actually angles at the center is twice the angle at the circumference. Yeah? So that's actually half of that, which is 27. Can you see that when we're doing the angles extended by the same arc, sorry, both points have to touch the circumference, yeah? And the center has got nothing to do with it. So here, it's actually angle at the center is twice the angle at the circumference, yeah? Okay. So angle ABC equals 27, and then you go angle at center twice angle at circumference. All right, yeah, good. Okay. All right, B, D, and E are points on a circle, center O. So again, we've got the center. Look out for the theorems that involve the center. So you can see radius meets tangent. Yeah. So that's 90 degrees. So that bit, if that's 35, that bit is 55. Okay, yeah. Okay, and I can see that I've got the alternate segment, so the angle between the tangent and the chord is equal to the angle in the alternate segment, so that's 55. So that's 90, so that's 90. Yeah? Can you see I've already marked on the diagram even before I've read the question, and that's what you need to get to that stage. Yeah? So ABC is a tangent to the circle, which we've done. BE is a diameter, and we just know it because that was 90 degrees. Angle DBE is 35. Find the size of angle ABD. So ABD is 55. And why? Because you first have to say angle ABE equals 90 degrees. Radius meets tangent. And then angle ABD equals 55. And then you just go 90 minus 35. Okay, yeah, good. Find the size of angle DEB, which is that one there. Yeah, okay. There are two ways of doing it. One, you can just keep it really simple. So you say it's 55. And the reason is angle between tangent and chord equal to angle in the alternate segment. Okay, that's the shortest route. Or what you could have said is why that is 90. So you say angle BDE equals 90 degrees, angle extended by diameter, and therefore angle DEB equals 55. Angles in triangle add up to 180. Okay, well, that one seems to have been the easiest way to get it. Okay, it's nice when you're spoiled for choice. All right. Okay, that's it for now. I hope that was easy to understand. In part 3, we look at slightly more difficult looking questions. They only look difficult, so we're not panicking. We're just making the diagram our own, so we're in control. All right? And remember again, you are in control. All right, take care, keep practicing. Until next time, bye.